You're sitting in a data science interview, and the interviewer asks, "Your experiment shows a 2% improvement, but the p-value is 0.8. Would you ship the change or run more tests?" Now, this question isn't about memorizing definitions. It's about showing you understand how to think like a data scientist. So let's break it down in simple terms. A p-value tells you how likely it is that your results happen just by luck, if, in reality, your change made no real difference. Look at the red curve on the slide. That's what the world looks like if nothing actually changed. The little shaded area on the side, that's your p-value. It's the small chance that random noise could have created results this strong. So, when your p-value is small, like 0.03, it means there's only a 3% chance you'd see results this extreme by luck alone. That's a strong signal that your result might be real, not random. Think of it this way: the smaller the p-value, the less likely you're being fooled by randomness. In data science, p-values are everywhere, from A/B testing to model validation to product experiments. They help you decide if what you're seeing is genuine or just noise. Let's take a real example. You're testing a new recommendation algorithm. The new version shows higher engagement, and your p-value comes out to 0.3. That means there's only a 3% chance you'd see this kind of improvement by accident. That's why we often use 0.5 as a benchmark. If your p-value is below that, your result is considered statistically significant. In other words, you can be fairly confident the change is real. But here's the key insight. Great data scientists don't just stop there. They also think about business context. If it's a small experiment, 0.5 might be enough. But if the decision affects millions of users or high-stakes outcomes, you'd want even stronger evidence, maybe a p-value below 0.1. Now, here's how you might answer this in an interview. A p-value shows how likely my result is due to random chance. A smaller p-value means stronger evidence that the effect is real. In experiments, I use it to decide when a result is reliable, but I always match the threshold to the business risk. That's a confident, thoughtful answer. It shows you understand the concept, the context, and the decision-making process.